Hi, I'm Jenny, and I'm a research analyst on the data science and research team at the Wharton AI and Analytics Initiative. And if you've ever been interested in leveling up your data analysis skills from something like Excel, I've created a quick introduction to some key R skills that can be supportive for your next project. For the next 10 minutes, we're going to uncover 3 powerful, underrated capabilities of R that you may not know about. I'll go over each capability with short code snippets and examples. This tutorial is meant to be beginner-friendly and clear, even with just a little background knowledge of Excel or data analysis. My goal is to provide enough context that this workshop is easy to follow, but I will not be going super in-depth into each topic here, and there's lots more to learn about R and each capability that we'll discuss. If you're interested in diving deeper, be sure to check out our other WAI AI workshop series videos, and I'll provide some resources for extra background on R as well. Today, I'll firstly go over a quick overview of some basic R concepts and terms, and next get into our 3 R capabilities of interest, which include web scraping for openly accessible public data, creating interactive reports, and making sophisticated PowerPoints. You may have heard of R, which is a powerful coding language and analytics tool often used for statistics and data visualization. If you haven't used R before, it's free open source software that can be installed directly from the R project website linked here. We'll be working with R via the RStudio interface from Posit. When you open a script or project in RStudio, it will open in this window in the top left panel automatically. The R console is where your code runs, and by default, it lives in the bottom left panel in RStudio. The top right panel shows the environment where you can see the data frames and objects created during your R session. There are many courses and tutorials available that go over R topics in depth, from basic syntax to advanced statistics and visualizations. I've included a very quick applied introduction to some concepts that might be useful throughout this R workshop series. Firstly, to open an R script, R Markdown, or Quarto document to save your R files, you can click File, New File, R Script, R Markdown, or Quarto document. When working in an R file, you'll be asked to set a working directory, which should be the folder where you save your file on your computer and is where R will look for files to read in, such as data, and will save any files that you write in your script, like visualizations. If you've used Excel but don't have a ton of coding experience, R coding is likely easier than it seems. Objects in R are values saved for future use in a script and can be created using the assignment operator, where the saved object appears to the left and the value it should contain appears to the right. Data frames are similar to Excel spreadsheets and are tables that contain different types of variables, where each row represents an observation and each column represents a variable. When you read data into R, you typically save it as a data frame and use it from there. Variables can take different types in R, similar to Excel data formats. A few data types you might encounter are character for text, numeric or integer for numbers, factor for categorical variables, logical with true or false, or NA for missing values. Functions are basically reusable commands that use code to carry out tasks with your data in R and are similar to formulas in Excel. For example, mean of the vector 1, 2, 3, 4 can be used to find its average. You can use pre-packaged functions from R packages, or you can write your own for custom tasks that you do often. There are many R packages that contain sets of useful functions available via the CRAN. To run the function you want from a particular package, you can write the package name before the function separated by 2 colons, which is helpful especially when you have multiple packages loaded in a session that contain functions of the same name. Comments are notes readable to humans but not read by R, and are written within code following a hash symbol. You can run code in R either by clicking the Run button in the top right corner or in the drop-down menu, or by hitting Command-Enter or Control-Enter keys. To troubleshoot errors with R code, you can search for errors or function documentation online. You can also see function documentation directly in the Help window in RStudio by running a question mark followed by the function in your console or script. Now, we'll get into a couple of things you might not know you could do with R for your next big project: accessing real-time, openly accessible data with web scraping, creating instant interactive web reports, and automatically generating and updating PowerPoint decks directly from R. Web scraping in R is super useful because you can easily integrate and continuously monitor any openly accessible, publicly available data online that might be relevant for your business, allowing you to stay updated with ease. Here, we will be looking at gross domestic product and population data for the top 50 largest metropolitan statistical areas, or MSAs, in the United States from Wikipedia, which I've cited here and included the link. This is the sort of data that might be relevant background for a variety of business questions and could be combined with other data for fascinating insights. We will only touch briefly on web scraping in this tutorial, but some websites limit access to certain uses or prohibit it altogether, so be sure to fully review, understand, and follow the terms of use of websites that you hope to scrape before doing so. It is also often best practice to avoid making too many scraping requests at once to avoid overloading website servers. Here, the first step for scraping openly accessible online data with the rvest and polite art packages is to introduce yourself to the website host and get information about the site's web scraping policies, which come from the robots.txt file here. We can next scrape this Wikipedia page and pull the table we are interested in. Looking at the raw data frame from the Wikipedia table, we can see GDP in millions of US dollars for the top 50 US MSAs. I'm next doing a bit of data cleaning to make this data more easily usable. I renamed some columns, shortened a few strings, and changed population and GDP variables to numeric. Just like Excel, if there are commas within a particular number, R will read it as a character variable instead of as a number. We can see how the data looks by displaying the top couple of rows in the data frame. Looking at the data frame preview, variable types, and number of rows, we can see that we are successful with the data cleaning. Next, we're going to get into how you can easily make instant, professional, interactive reports for your business in R. We'll use this tutorial as an example. Using R Markdown, as I do for this tutorial, or using Quarto, you can easily generate reports that impress stakeholders, investors, and internal teams. By integrating plots and data directly into reports from R, you also minimize the risk of error and easily can update and reproduce reports. We will discuss a few concepts that are helpful to customize your reports, and lots more information is available at the R Markdown or Quarto documentation online. The first part of an R Markdown or Quarto document is the metadata. This lives at the very top of a file and specifies cross-document settings. For example, you can set the document title, author names, and date to be printed at the very top of a finished report. You can set the document type to be created, for example, HTML, PDF, or Word documents. You can indicate whether to include a table of contents and how it should look for HTML reports. And lastly, you can choose a report theme from a set of pre-made options. Advanced visual customizations can also be done using CSS. Markdown text written outside of code chunks in R Markdown or Quarto reports can be customized as is done throughout this document. For example, with headers preceded by hash symbols denoting their level, text bolding with 2 asterisks or italicizing with 1, and inclusion of ordered or non-ordered lists with numbers or bullet points. R code chunks are written inline, and their behavior can be specified within the curly brackets at the top of the chunk, which can control, for example, whether or not code chunks and their outputs are shown in a report. In your reports, you can easily integrate tables and data visualizations using code chunks. For these examples, I turned the echo, warning, and message settings off for each chunk, so code is used to create visualizations and tables, but we don't see the code itself or any extra messages or warnings it outputs in the final report. When you're ready to finalize your report, you can render it by clicking the knit button, which will save a finalized report to your document directory by default. Rerunning knit will overwrite the report file whenever you make updates. You can update knit options via the drop-down menu. With some exploratory data analysis tables, we can easily examine descriptive statistics and distributions for GDP in millions of dollars for each MSA and descriptive statistics on the 2020 population across US cities. We can also create data visualizations for reports directly in R. As if this were a real report, I followed data visualization best practices, for example, including clear X and Y axis labels, titles, and captions, using consistent color schemes, and including minimal extra information on plots so that key findings stand out. If we visualize the progression of GDP by MSA over years with a line plot, we can show this with a static visualization made in ggplot2, or we can easily make it interactive with the Plotly package. To examine associations between GDP and population in these top 50 US cities in 2020, we can use a static scatter plot, and we can print the correlation coefficient directly on the plot. We can make this plot interactive as well. Stay tuned for more details about creating and customizing interactive plots in R in an upcoming workshop. These are just a few examples of how you might create a report including some data visualizations and tables for your stakeholders. You can easily hide or reveal code, change themes, and customize how you're presenting content depending on your audience. Lastly, we'll discuss how to automatically generate PowerPoint decks in R. Similar to creating reports, creating slide decks in R saves manual time and effort, ensures your presentations are always accurate and aligned with current data, and makes them easy to update. We can easily create slides integrating visualizations and tables directly from R code and data, either by setting up Quarto or R Markdown files with a PowerPoint output, which we will do in a future tutorial, or by using R packages, which we will do using the Officer R package here. To put the same tables and data visualizations from our report into a blank slide deck, we can start by creating a new deck using the read pptx function. This creates a blank deck by default, or we can replace it and add a template as I've done here. I made the template I'm using in PowerPoint and saved it to the same folder where my script lives. We can then set a default slide type for new slides, and I've done that using the title and content slide type here. From there, we can add each slide we want, which will use the default slide type unless specified otherwise, and we can add content to each slide directly, such as titles and our tables and visualizations saved earlier. Lastly, we can save the finished slide deck to the working directory folder. And the finished product is ready for presentation, as you can see, showing the same tables and visualizations we created earlier for our report. In this workshop, we discussed a few fundamental concepts in R and used R code to scrape real-time, openly accessible data, create instant interactive reports using this tutorial as an example, and automatically generate a PowerPoint deck for easy updating. In our other R workshop series videos,